Perfect. So yeah, we're live. Welcome everyone to the second workshop of the Nibiru hackathon. Today we have with us Kevin, who's the co-founder at Nibiru Chain. Hi, Kevin. So
Hi.
yeah, before I think getting right into it, and before getting into the technical part of the workshop, Kevin, is there any opening thoughts that you would like to share with the hackers, devs watching us?
Yeah, I just want to say thank you so much for participating in the hackathon and building on the Nibiru. Really excited to see what you all are building and excited to build the ecosystem together.
Perfect. Thanks, Kevin. And for everyone watching, feel free to put any questions, comments in the um, comment section of the live chat. We'll be happy to take it up during or after the presentation. But yeah, let's make it a little more interactive. Over to you, Kevin.
Yeah, so today I just wanted to show how I debug things personally, locally. I find that it's easier to debug locally instead of having to deploy to like a test net every single time. And then once that iteration loop is faster, then you can deploy to testnet or mainnet when it's ready. So I actually wanted to share my entire screen. Yeah. Okay. So there's an infinite window, which is good. So the first thing that I wanted to do is clone the Nibiru repo locally. So this is the blockchain repo. It's primarily written in Golang, but has the WASM extension. So that's how you deploy the Cosmos WASM smart contracts. Um, you can run any of these commands to clone it. I've already done so. So I'm going to go over to my terminal and you can see that this is my local repo that I've cloned already. Um, let me make the text a bit bigger. There we go. So the first command that I'm going to run is just make local nets. You run that, and it runs a shell script that compiles the binary for you and starts running a blockchain on your computer. This can run on pretty much any laptop, so you should be able to already have a blockchain available. So then you can run stuff like um, you can query like the bank for balances on. Well, first I should tell you that it creates a address for you. This is in the localnet script if you want to take a look. But this is the validator account that's running the blockchain on your computer. You can already run queries against your blockchain running right now using our CLI. So this is going to query all the balances for that account that was created at Genesis, and then you can see some tokens it already has. UNIBI being the native gas token, and then these are just dummy stable coins that we added to so you can play around with like liquidity applications on the blockchain. All right. One thing you will notice is that you get these errors every single block. It's basically saying that there's no price feed or there's no oracle on the blockchain right now, and that's because we every validator has to run a price feeder as well. So that's the next step we're going to do. If you don't do this, if you don't post prices of the validator, you'll eventually get slashed, and your blockchain will end because you're the only validator. So we don't want that. So we actually have a reference implementation of a price feeder. You're also, of course, welcome to write your own, but we do have one at our price feeder repo. So again, you're gonna clone this um, and run it locally. So I've already done that in this tab. This is my price feeder repository. In this repo, I'm going to call make run. And what this is going to do is it's going to compile the binary and start running it. There's some initialization it has to go through, and then eventually it will start posting prices. So this our price feeder implementation is set up to pull data from, I believe, CoinGecko and Binance, and then it selects one of them to post prices. So you can see it's starting to post prices for a bunch of pairs that we've enabled on the blockchain. And now you have a price feed. So now if we go back here, all the errors that were above are now gone. And now you have prices on the blockchain. So we can actually verify that by looking at exchange rates. Yeah. So these are all the prices that we have. So Atom is at 8.968. Yeah, you have, let's see, ETH at 1918. Yeah. Okay. So that's that. So now we have a running blockchain on your local computer. Um, Now we can do a bunch of other cool stuff. So for the hackathon, what you're probably doing is deploying Cosmos smart contracts. I believe there was another workshop to talk about like the development of Wasm smart contracts. So what I'll be going over is actually more of the deployment and how to debug the Wasm smart contracts. Um, so we actually have a reference some reference smart contracts in our CW Nibiru repo. So this one has all the contracts that our team wrote. So we have stuff for incentives or bindings. There's also the Cosmosm team themselves have like this Open Zeppelin type repo called CW Plus, where they provide reference contracts for a bunch of different specs. So, for example, CW20 is kind of like ERC20, where they provide a fungible token spec. So these are all valid smart contracts from either the CosmWasm CW Plus repo or from our CW Nibiru repo. I'm going to use CW Nibiru for this demonstration. So again, you're going to clone it using whatever method you want. I've already done that. So I'm going to hop over back here. This is my CW Nibiru repo. Check out main. Yeah. So in here, you have all the source code under contracts, right? It has a bunch of subdirectories with source code in them. And then if you compile all of these, we'll end up is a bunch of WASM files in the artifacts directory. So these are the actual bytecode that you need to upload to the blockchain. And we're going to do that on our local running blockchain. Okay. So what I need to do is run a command to upload the smart contract. So again, I'm in the CW Nibiru repo. What I'm going to do is nibd tx wasm store artifact slash, and then it could be any of these wasm files. So I'm just going to do a random one like findings perp. And then you need to specify some extra information like from validator. You need to specify gas. So the gas is a interesting one because the gas actually depends on the size of your contract. So how many bytes it is. It's hard to predict that a priori, but what you can do is you can take advantage of the SDK's simulation feature where you can do gas auto and gas adjustment 1.5. Gas auto means run a simulation of the transaction and then tell me approximately how much gas it'll cost. And then gas adjustment is a little multiplier you apply to that because historically the gas simulation always returns like a slightly smaller value than what you actually need. So you just we just apply a multiplier of 1.5. You could also use 1.3, but 1.5 to be safe, and then confirm it. Um, here we go. Yeah, this happened because my price feeder was also using the same account and same mnemonic, so it conflicted. But yeah, my transaction went through. Um, so this is my transaction hash. It doesn't have the information here because I need to now query the transaction hash from the blockchain. And then you can see the results of the transaction here. This is essentially what we put into our Explorer. And kind of like a mint scan like experience. But this is the raw payload in JSON of what we parse to then put in our Explorer. So yeah, there's a lot of events and attributes here that we look at. This huge payload over here is the base64 encoded bytecode. So this is literally the smart contract in binary. But what I'm looking for here is actually the code ID. So how WASM smart contracts work is a little bit different from Ethereum. Cosmos smart contracts require you to upload the code as like a package, and then you instantiate instances of the smart contract using that uploaded package. So what I did was I just uploaded the package by calling store code. It gave me a code ID, and now in order to create a copy of that smart contract, I need to now instantiate it using another transaction. But I need this code ID first. So now that I have the code ID, which is 1 because it's the first smart contract on my local running blockchain, I can do Nibiru TX WASM instantiate 1, and then it's going to ask you for an instantiation payload. I think for this one, I can just put empty, empty JSON payload. It needs a label, so I'm going to call it workshop demo, no admin, and then from validator. Yep. Again, I get the transaction hash, so I need to query it. And here we go. So this is the output of that transaction. It succeeded, and it gives me back the contract address. Right. So now this is my smart contract on the blockchain, and I think if you yeah, you can see that I have successful transactions on my local running blockchain. This is from either the price feeder posting price transactions, or from me just uploading the smart contract. Okay. So now that that's there, what I can do is I can now call it txwasm and execute. What I can execute is I need to do this, and then I need to check the payload for what it's looking for. So this is specific to every smart contract that you deploy, but you have to look at the messages and see what you can execute. So market order. Maybe there's a no op. Okay, let's try no op. Message invalid. I wonder if it's like this. All right. I have to double check the payload, but essentially you can execute your smart contracts now locally by doing this. All right. So that's that. And smart contracts. Okay. that is how I would debug and deploy smart contracts locally. I'm gonna pause there if there are any questions in the chat before I show one more thing.
I think for now, Kevin, it's all good. Looks like everyone is on board with you, so yeah, no questions for now.
Cool. Then I'm gonna show another cool thing that you can do to test and debug your smart contracts locally. Um, so one thing that really helps with development is being able to debug your code and step through it. Um, it's pretty doable in regular binaries like Rust binaries or Golang binaries, but with smart contracts, it's a little bit weird because in order to execute a smart contract, you have to have a live instantiation of it. But there's actually a way you can debug smart contracts locally. Um, I've done this in VS Code, but you could probably do this in other IDEs as well. Uh, in VS Code, you need to install two plugins or extensions. One is the Rust Analyzer, which provides static source code analysis for Rust, especially the Rust language support for VS Code. And then another one is called Code LLDB. This one. You need this one to be able to debug a Rust contracts or Rust code. So once you have a smart contract written like this, you'll always want to test it, of course. So you have a test module. Um, and then you see that this example is from Cosmosm's CW Plus repo. It's the CW1 whitelist. CW1 whitelist is essentially you can read the description here, but it's essentially like it kind of acts like a multi-sig where or a one-of-one multi-sig where you have a group of admins on a smart contract, and any admin can execute a message proxied by that smart contract. Um, So the reason why I picked this one is because it comes with like pretty good test coverage, and I wanted to show you how you can test the code and debug it. So, for example, the first test we have is to instantiate the contract, and then it does some updates to the contract. Um, so let's see. Looking at the code, right? You have Alice, Bob, and Carl, and anyone. You're just strings, but you can think of them as people or addresses. You instantiate the contract with this instantiate message. And then if you want to verify that you're actually sending the correct message over, you can set a debug point, a breakpoint in here, and then start debugging the contract. That will bring you to a breakpoint, and then now you can step through the code and inspect local variables. So I'm creating this instantiate message kind of in line right now, but you can imagine like if it was a more complicated function and you wanted to verify its output, you can set a breakpoint here and then verify the instantiate message. So you can check who the admins in the message are. So it's Alice, Bob, and Carl. It looks okay. Step through, and then let's say you have this assert and you have this like query admin list and this expected one. You run through here. Your expected is this, and then your query admin list. Let's see. I can debug here. So I got through here. Yeah. Step out. So the admin response is config.admins. Oh, I already got out of the scope, so the variable is gone. Okay. Let me rerun that. So I'm in the instantiates. I want to stop on the admins. So let's go through here. Okay, config, admins. All right. So now I'm in the internals of this query admin list function. The CFG variable is actually loading objects directly from state. So you can see exactly what state objects are being loaded. You have Alice, Bob, and Carl, right? So now if I step out this, oh, I'm stuck inside the stack trace. All right, let's get out of here. Okay, so I can actually very easily go in and assert that my query function is returning what is expected. My expected is, of course, Alice, Bob, and Carl. And then we saw earlier that if you go inside, the state was loading Alice, Bob, and Carl. Okay. Okay, we want to, the next test is that this any one person cannot modify the contract. So this one is an update admins. It's gonna call this one. And then let's see what happens when we go here. So the next test is going to jump into here. And yeah, let's see what happens. We step through and it returns the unauthorized error, which is what we want. So yeah, I won't go through all the tests, but essentially you can use this trick or this feature of the language to basically debug the state of your contract before actually having to execute it on the blockchain, which will probably save you a lot of time because now the iteration loop is a lot smaller and you can actually see exactly what's going on. Definitely make really good friends with debugger. Debugger is probably one of your best friends in development. And yeah, that is it for now.
Perfect. Thanks a lot, Kevin. And yeah, I think this is a great opportunity for the developers, hackers watching us. We at DoraHacks are definitely very excited to unveil InnovateX for the hackers. We have an impressive prize pool of 150K dollars in the native token. And yeah, I think building on Nibiru which stands out in the evolving DeFi ecosystem. This is a great one-stop shop for the full stack user experience. So definitely get your hands dirty and thrive in the evolving ecosystem. Kevin, maybe you want to share with the developers the ideal way to reach out to you or the community in case there's stuck upon anything.
Yeah, so the best way to reach out is to jump into our Discord. Um, that is how probably that's probably our biggest community right now, where a bunch of other developers can help, and we also look at the feedback very closely. Um, you can also reach out to us on Twitter, and yeah, if you have any questions about the hackathon itself, please also reach out to DoraHacks, and then they will also relay questions to us if they can't answer it themselves. So yeah, those are some good channels to reach out to us.
Perfect. And all the links, developer links, the social links, group links, Telegram, Discord, etc., would be updated in the hackathon page on DoraHacks.io. And all the best, everyone. Um, Happy time building and breaking. Thanks a lot, Kevin.
Thank you.